Okay, good morning, everyone. I'm Kijin Song, and I'm a postdoc researcher in the Urban Information Lab in the School of Architecture at UT Austin. Welcome to our lightning talk series on smart city research. And this talk series is funded through the UT Good System project, and we invite the speakers from academia, industry, and the communities to share the research events and the needs related to the smart cities. So if you are interested in the topic, please feel free to visit our website for our past talks and other activities at smartcity.tech.utexas.edu. And for today, we are very excited to have Dr. Xinye Ye as our guest speaker today. Dr. Ye is Fellow of American Association of Geographers and a Fellow of Royal Geographical Society, holding a Harold L. Adams endowed professorship in the Department of Landscape Architecture and Urban Planning at Texas A&M University in College Station. He directs the focus of transportation in the PhD program in urban and regional sciences at Texas A&M and is the interim director of Center for Housing and Urban Development and the founding director of Urban Data Science Lab. His research focuses on geospatial artificial intelligence, geographic information system, and smart cities. He was one of the top 10 young scientists named by the World Geospatial Developers Conference. His work has been funded by National Science Foundation, National Institute of Justice, Department of Commerce, Department of Energy, and Department of Transportation. Professor Ye is now editor-in-chief of Computational Urban Science and the co-editor of Journal of Planning, Education, and Research. His talk for today is titled at Design and Analytic System Based on the Urban Artificial Intelligence. So without further ado, I'll pass the mic to Dr. Ye.
Thank you, Kijin, and thank you everyone attending my talk. Today, before my talk, I want to also acknowledge my recent 6 NSF grant support, which allowing me to further explore cities as a complex system. And for me, it's not only understand the complexity, I also think about how to harnessing the complexity. If some of you pay attention to last year's Nobel Prize in Physics, it was awarded to 3 scientists and try to understand the climate science and the complex system. I will not go into details of what their academic contribution is. However, look at why they award the complex system is they argue the 3 scientists find order in disorder. Yes, we see lots of disorders in climate and weather, but similarity is in the urban system and urban development. Our increasing urban coastal development make it necessary is we need to have more science-informed design, planning, and management. At the same time, our infrastructure data does not only mean the physical infrastructure. We have the social infrastructure. We have cyber infrastructure. How we integrate all these 3 infrastructures into an analytical platform, allowing us to play scenarios for real-time, virtual, augmented, and dynamic testing. It is increasingly important, especially in the past 3 years, in the COVID, and we also face various challenges in the climate extremes. Many things we think we might not be able to see in our lifetime, but in past 3 years, we have witnessed many like 100-year events. So at the same time, the planning, all our designs become increasingly collaborative. It means our decision need to be fully shared, engaged with local residents, experts, policymakers, and practitioners. Our design and analytic system are facing these challenges because our ongoing system are very top-down, expert-driven. So lots of kind of motivations or the opportunities here, but the challenges exist is if we want to do anything, we need some readily available source of information for updated local data. I have been working with Texas Statistical Data Center located in A&M College Station. They have the restricted access data. For that, it means you cannot publicly access the data. However, they have very detailed local data. So we are coming up, working on some projects is whether we can develop some ready to use data when there's a disaster for researchers come to the like the restricted access facilities. You can immediately combine your data with our detailed local data for some quick decision making. At the same time, we lack the high resolution contextualized spatial temporal information. So in other words, our data is reported by category. However, all these data have some spatial temporal information which we can link them. We are kind of missing some important methodological framework allowing us to contextualize data into the data. So I will talk about it later. And the other difficulty is we do not have near real-time empirical data from real disasters describing how the communities transition from recovery to, for example, to adaptation. And last but not least is how we engage our stakeholders in the project development and the risk assessment. For that is, as I said, is a complexity system. The good thing of that is we want to find order in disorder. And to do that, I would argue is we need to identify local information and emphasize that collective kind of knowledge are very key components. Our plan is develop a digital twin infrastructure with integrated decision support components, which allowing us when we have the digital twin infrastructure, that means we integrate the cyber, social, physical data system together, which will cause, I would say, the endless convergence and the frontier for research and practice. So what we have been developing at A&M is something we call either urban or built environment digital twin, allowing us to observe and monitor vulnerability of coastal infrastructure. Certainly, you can apply to other like border infrastructures. We model the infrastructure vulnerabilities and the people and their interaction, allowing us to predict the impact. The essential thing is we can do many what-if scenarios in virtual environment for decision making. So this is kind of the flow chart of what we are doing for the what we call is build is like a brewing of social physical convergence for digital twin to integrate the data, facilitate the communication, engage and educate our local communities, and also actually engage and educate our fellow researchers. We learn from each other, right? So for that, the idea is from last century, there's a famous Yale University's computer scientist called David Granta. He published a famous book called The Mirror Worlds. So what we are doing actually is we are mirror our urban worlds into another kind of digital environment, into a computer. For that, we feel safe because that's how we test in real time, then send back to the real world for decision making. We use Galveston as an example. We have been developing some digital twins to allowing us to better understand how we link the human and the social centered data for the coastal communities. So the nowadays utilizing the digital twin to better integrate different missed items or missed linkages for the better prediction is increasingly become a trend in internationally. Like ESI this year, just some month ago, they reported the climate change makes Grenada is a small island to create the first national digital twin to deal with climate change. And we would also argue is with increasing possibility of the artificial intelligence in natural language processing, computer vision, network science, heterogeneous graph transformer, we are able to link the data from the macro level all the way to the micro level, from the metropolitan scale to the building level, to link data together for us to better predict what's the outcome of various designs. So for that is, for example, we use the for the flooding as example. The basic unit to analyze flooding impact is at the house level. In each house, we can develop ontologies to find out what's the type of the house, what's the relationship of the with the other house, with the other spatial entities, and the component, or even we divide the house into components, and each component will have its property. So we utilize a scene graph to organize kind of these visual elements into a network. So when they become when the visual elements are networked, and it will also be allowing us to link the connection to its history, and also link to its proximity, and link to its broader regional context. So it will become network of network. So again, it will utilize the idea of complexity system. And not only that, is for each building, we are here we have 17 different research design criteria relevant to this building. So in other words, we transform a picture to a group of design criteria. So you think about it, you have many such pictures in a flat plane or in any places you think is at a risk. And we work with architecture designers, and they utilize the design criteria to translate your picture into a link to a group of design criteria. So when we collect, so I will call it collective knowledge based on a group of architects, they will be able to see, telling us, doing the annotation of the picture, and we can use any like images we send in a specific house, or they will can retrieve the similar images based on the design criteria, and it will allowing us to match various design outcomes, and also we can even give the scores is based on how good or how bad the design is. So the difficulty of the urban kind of digital twin is we cannot just let's say to throw the data into that. Digital twin, the problem is when we throw data in, we don't have any contextualized data. it's as if when you build a library, you just throw books into a library, but no one will really be able to read. I will not say most of books, even read 10 or 20 of the books. So for that, we are developing some new methods is how we can, based on the street view images and other field images we took from the field trip to identify their doors, because it allowing us to find out what's the first floor elevation. In a digital twin, the typical thing is we want to make our data 3-dimension. The 3-dimension, the first thing is look at a house. What's the first floor elevation? Because if the flooding come into the first floor elevation, it will change, it will bring the incur the insurance cost to the building, right? It will really bring the cost of the flooding. And for that, we develop many methods to identify where the first floor elevation, and we apply it to the Galveston Island in here, and the R square is almost close to 86. So in other words, we can utilize this to replace many of our on-site measurements. However, as I said, in the difficulty of building the design and analytics system for the decision making in the urban area is we do not have contextualized information. What does contextualized information mean is, if I just give you a map, but I never tell you any information about the locations, so you don't see any difference between the downtown Detroit and some other downtowns, right? But if I send in some people to tell you, wow, don't walk through this street, it's dangerous, and many people get robbed in that small like a street, avoid going through this way. Or I would say, oh, no, don't walk slowly in this location because it's underground drug market. So for that, no one will write the drug market or it's a shooting place on the map. However, local people know what's going on. So we develop some methods, is the tools allow people to come into this is a campus of a university, and then they talk when they walk around, and we can link the specific location, the street view image, with all the other images we took with the corresponding statements. So in other words, we contextualize our information. And for that, we also consider protect privacy. So we develop these polygons. Within these polygons, all the data will use the same location. So for example, we assign the centroid of the polygon as where all the data go to. Okay, so and even for that, we can find out what the similarity across the polygon. So, so that's the reason why you find out in certain places of the cities, you find out many similarity. The similarity is because of your visual impression, right? And also other underlying socioeconomic attributes make the two regions similar. Well, here is we want to utilize both people's narratives and the physical data all together. For example, we can build a multi-dimension matrix to compare the similarity. And not only that, because we ask people to talk, to speak, and we can also link the different images, the similarity based on they use similar keywords. Or certainly we can semantically, they are similar. There's many cutting edge natural language processing packages we can use. So in other words, is our data, when you get any kind of data, the data is provided by different agencies. For example, it's from transportation, this is from the 311, and that one is from police department. And that's not their responsibility to connect the data to the local environments, let alone they tell you a story, right? Remember when we were kids, our first training is tell us, oh, this is apple, this is orange. That's the first training. The second training is our teacher will give you a picture, ask you to, based on the elements in the picture, can you tell me a story? So that's how human beings train to tell stories. However, our current data sets do not have any story there. These stories need to be enhanced by our local field trip or from our opinion leaders, our local residents. So that's, I can say that that's an approach to link the separated data as one system. So we in our data analysis, we utilize the both street view images. We also use our own taken images. If you go to Google Street View website, you find out the Google Street View recommended several devices allow you to take your own Google Street View images ranging from $300 to several $1,000. And for that, you can help the city to update the street view, right? If you find out some locations street view updated too slow, so you can go to update by yourself, right? So that's how cities build the memories. In that is city is more like a time machine. You can have more nowadays. If you look at the cities, you have multiple like the years street view images. However, sometimes maybe it's not just fall into your research question time period. So the easiest way is you can go to buy a $300 device to get the street view by yourself, and then utilize the methods I suggested previously to analyze the depth of the image to identify their elements and locate them. The other thing is we need to argue is our urban digital twin for any data analytics, it should be human centered. If nowadays you go to the Google Street View, Google Maps, like I just type, say how I can walk from Fisher Plaza in College Station to the main campus of Texas A&M. They provided me multiple route possibilities, but they never asked me whether I'm on the wheelchair or I can walk by myself, whether I'm a person, whether the sidewalk exists on the roads or not. They don't care. So for that is, if there is a kind of the broken, if there is a sidewalk is there, but the sidewalk is broken, and if I'm the wheelchair, there's no way for me to jump from one side, one side of the to the other side, right? So we for that is, as I said, is we built in quite a few analytical. When you want to design people's working route, or you want to design some new approaches to enhance people's workability, you need to have the strong analytical components in your platform. For that is you need to combine the remote sensing analytics and the visual analytics, because remote sensing help you to find out where are those routes. However, there is some disconnection between the routes is because it's hidden by the canopy of the trees, or because of the building, they have some building parts just stretch out, and you have no idea whether there is a sidewalk below that or not. Then we use street view to identify whether there is a sidewalk. And for that, it means you need to combine the remote sensing image and automatically go to check whether there is a sidewalk below. So if yes, then this segment need to be merged. So so we developed many new methods. Is how about we can restore the routes of the sidewalks by identifying whether there is a tree, use segmentation to find out whether there is a sidewalks below that. So for that, it will save our efforts. Otherwise, you need to use a street view image to identify every of that. It's impossible if there's a very large area. Okay, so we utilize remote sensing and street view together. And we recently, our new approach is using the heterogeneous graph, because when we talk about scene graph, when we talk about street view and talk about things you will find out in the city, we have many agents, we have here many individuals, we have organizations, we have the institutions, right? We have nonprofit organizations, we have universities, many of that, and we have church, we have the we have definitely have lots of volunteer groups. At the same time, we have many point of interest, and within the point of interest, we have another point of interest. We are in a big shopping mall, and a shopping mall, inside of a shopping mall, we have many different stores, and in different store we have different salesperson, and we have different visitors. And we also have parking lots. Sometimes because your parking lot is broken, no one like people really reluctant to come to visit the kind of your shopping mall. And at the same time, sometimes the reason is the outside the traffic is too bad. So in other words, we have the system of system. We have many heterogeneous kind of the nodes, relationships in our world. That's the truth of our world. So we are developing some heterogeneous graph transformer, or link all of them together. So the recent in research we are working with the University of Virginia is we look at how individuals they spend their money in a city. For example, we purposely look at how people go outside to eat, then looking to how different people they stay, how long time in certain places, and where they live, and whether the restaurants, what's the menu of the restaurants, how much is the price for each item, and whether they play piano during the business hours. So then it will come to another question is, if I spend, let's say, lots of money to hire people to come here to my store to play piano, whether I will be able to get back my investment. Then it means it's not because of you, it's whether how other stores play pianos. So that's if you further expand, think about it, not a city, it's more like in a region, how cities compete with each other, right? For different policies, how you should use different policies. And we also have a kind of organization in called the Institute to how to promote a small town America, to allowing the low income small town also have the smart city technology. So we are developing some combined with limited public transportation, and also has autonomous vehicle and helping the people move around, and also for telemedicine use. So so as I said, you will also need to educate more using more plain language, is how AI can help to planner designers for the flood resilience. So last but not least, as I said, is my research agenda to harnessing the complexity by integrating all the cutting edge methodology advances with linking with the needs of our urban system, the communities, to turn our space to place from concept to deliverables. And the key issue is the integration of all kinds of data and the user story and localize the information to link them. So if we also run 2 journals, the computational urban science and the journal of planning, education, and research, to promote these ideas. So I think that's all for my talk, and thank you for your attention.
Thank you so much, Dr. Zhao, Dr. Ye. I think, yeah, that's a very interesting talk. I'll just wait to see if there is any questions from audience. Does anyone have a question?
Dr. Ye, sorry I was late. I was in another meeting at the conflict. I caught the second half of your talk. Very, very interesting. So to kick off the question, I have a quick question. So what do you think the relationship between urban planner and computer scientist in terms of smart city research? Most likely, from my experience, what we doing, they can do better, do faster and easier.
It's a great question because I have been working with computer scientists. So when I started my job 12 years ago in Bowling Green State University, because at that time, my relationship with computer scientists is I needed their help to make my tools more robust and I can pass some computing bottleneck because the large data sets is sometimes make my tools very slow, and if especially on the website is a nightmare to me. Is when you try to do a real-time demo and it's always a broke. So I need some computer scientists to stay with me. Then I will have a strong confidence is go anywhere to present. And then later when I talk with them, I realized we have different interests because to them is make your algorithm faster and make there's no broken in computing, and to them is a top priority. And especially if you look at what they do, they have the open data sets. They can easily verify each other's speeds in dealing with the same data sets to see how fast you are, to see what kind of new things you identify other people do not identify. Then I find out the problem is our world is not an open data sets. And we have many inconvenient data set, especially sometimes we need lots of the back and forth interpretation. But that's certainly not their interest because their interest is you make the old data ready for them. They can certainly use the algorithm beat any of our algorithm. But as I said, is bring human in the loops. And why human in the loops? That knowledge is not a computer science knowledge. That's our knowledge. So that's I feel more and more confident is when we talk with computer scientists, when we are not only is one side relation, one side direction is we need their help. And when for the knowledge of human in the loops, they also need our knowledge. That's one thing. The other thing is about deliverable. The deliverable things. Who you deliver this kind of outcome to? Are you delivering to the large computer science community is saying, hey, how fast I am? Or you use that to communicate with local communities and policymakers. To us as either geographers or urban planners, working with communities to empower communities are our top priority. If our research cannot impact the communities, then we are using our shortcomings or to compete with other people's strong points. So connecting, engaging communities will make us even become more important in this research. So now my relationship with computer scientists now is becoming very normal. Is in certain circumstances, certainly they can take a lead in the project because it's very computing oriented, algorithm based. But on other side, if it's very much will emphasize social impacts, emphasize the deliverables to the policymakers, then we can take the lead. Yes.
Thank you, Dr. Ye, for the answer. Very useful and very interesting. And student, do we have other questions for Dr. Ye?
Yeah, feel free to ask. You can ask any question.
Yeah, I just wanted to point out, I think you pointed a really important thing, that the digital twin should be human-centered. And I think it is basically the role of urban planners who always should consider some social impacts and some disadvantaged peoples who can be easily marginalized from the urban technologies. So like you said, I think also the deliverable to the community is really important part in the developing the digital twin. Yeah.
I think that when we talk about in the our urban informatics or big data analytics, we also say, yes, we want to engage communities, especially for low-income minority communities, and for those people who are get less educated. It's easy to see it as a slogan. However, these challenges also need to be have the technical solution. For example, I have been recently, I have worked with my PhD student, is we look at the urban planning public hearing, and you have different representatives come actually for represent interest groups to talk. Now my concern is for some really is low income communities, how even you don't have the very strong local opinion leader who can represent your interests. And if you want to talk, want to argue, you cannot be as strong as other communities, which is wealthy, and they can hire strong opinion leaders, or even themselves have quite a few scholars represent them. Then I'm thinking about is if I do not, it's almost like I come to, if I cannot speak any academic language, I don't know how to cite the evidence to support myself. How should I do is, can I develop a kind of the AI system? Is I only need to tell the AI what I want to say. The AI will help me to organize the strong evidence for me. So it will empower the communities, because our community by nature is we have different education levels. And for example, in the we visit some border communities, they really don't have money to hire the urban designers to help them to deal with their kind of landscape, because you will find out they are lacking park, or lack the workable system. It's not because they don't have such lands, it's because they don't have the money to hire people to do that. And so the AI is to some extent it's become our assistant. Is that possible? Is we develop this kind of system to help the low income or those communities which lack the technical capability to enhance their capabilities. So that's I have been thinking, and I asked my PhD student work use this to as his dissertation topic.
Thank you so much. Yeah. All
Yeah.
right.
Yes. So in other words, is I think AI is not just only helping us to collect the data, analyze data, is also helping us to find out the capability issues of the communities to enhance those which lack the capabilities.
I see. June also has a question.
Yeah.
So speaking of that, the only concern that I have with all of using this high-tech computer science field technology is that I think it will be working as a barrier for local stakeholders or residents to understand, because it's becoming more high technical. Like we install the free highways in the beginning, the planning field, and people kind of had a confusion about whether having them or not. So were there any efforts to kind of mitigate those barriers so they can kind of participate in perhaps during your pre-processing data stages, or even in the collecting of street view images? Were there any like local residents efforts or their participation involved in this process?
Okay, it's a great question. Think about before Google, we have Google Map. Many people's understanding of maps is because through the department of geography. Like geography itself is not a large department. So the maps, knowledge of maps is very much limited to a small group of people. After we have the Google Maps, especially building these kind of navigation maps into your vehicle, then quickly everyone becomes the experts of the using maps, because behind that is a digital interactive map. There's many technologies built in. However, it looks like so close to our daily life, and people can easily accept that. So that's a similar thing is we have smartphones. Smartphones have many apps, and behind all the apps, they have artificial intelligence technologies. But when you make is so that's another thing, how we package our academic purpose in a more like a daily life flavors. So other people can easily accept, as if at that time people accept the Google Map, accept the cell phone apps.
All right, very interesting. Is there any questions? Okay, so I think we are ready at the time to wrap up. So yeah, I want to stop here. If you have more questions, please feel free to reach out to Dr. Ye directly, and you can see maybe, yeah, Dr. Ye, you can share your email address to the chat. And if you miss that visit, then maybe you can feel free to send us an email. We're happy to contact you with Dr. Ye as well. So thank you so much, everyone, and Dr. Ye, for your wonderful talk.
Yeah, thank you. I also want to say is because starting from this semester, I will take over the center directorship for the Center for Housing and Urban Development. At the same time, my lab proposal for design and analytics system for urban artificial intelligence has been formally approved by Texas A&M, the Data Science Institute. So we will have many activities ongoing soon to facilitate these kind of urban artificial intelligence in the context of housing and urban development at A&M. And yes, I really look forward to our many interactions, and hopefully we can see face to face in person soon.
Yeah, and I also hope to have some collaborations with you and Texas A&M in the near future.
Okay, thank you. Thank you for your organization.
Thank
you.
you.
Charles' vision in setting up this kind of series.
Thank you so much, Dr. Ye. Also, please share the PowerPoint if you can with Katie.
Yes, I will.
Post it online. Thank you so much, Katie.
Thank you so much. Yeah, thank you everyone for joining the talk. Have a wonderful weekend. Bye.
Thank you. Bye-bye.
Thank you.